Good morning, my dear students. I welcome you all for today's Embedded Systems and IoT Lab class. Today, I am going to give a demo on to calculate the moisture content by using the moisture sensor and Arduino. So, today we will see how to calculate the moisture content by using the Arduino and moisture sensor. Okay. So this is the I'll go through the in brief related to the experiment through the experiment manual. So I already mentioned that today the experiment is related to the experiment 9, that is calculating the moisture content in the soil using the Arduino. The aim of this particular experiment is to calculate the moisture content in the soil using the soil moisture sensor using the Arduino. The principal aim of the experiment is to calculate the moisture content in the soil using the soil moisture sensor using the Arduino. The hardware components required are the required Arduino UNO and a soil moisture sensor. Okay, mainly this soil moisture sensor which measures the water content in the soil and is commonly used in plant monitoring systems to track the moisture levels. Mainly it consists of two probes. When inserted in these two probes are inserted in the soil and these acts as the electrodes. Okay, the sensor sends an electrical current through the soil. The wetter soil conducts electricity better and which providing the higher analog output while drier soil provides the lower output. Okay, the whenever there is a wetter soil, it conducts electricity better and provides the higher analog output. Whenever the dry soil provides the like is there, it provides the lower output. For wetter soil, it will provide the higher analog output. For the dry soil, this particular sensor provides the lower output. And regarding the wiring, I will show that entire wiring procedure by using the Autodesk Tinkercad software. And this is the how the circuit diagram is related to this particular our experiment related to the calculation of moisture content by using the Arduino. We are using the Arduino board and this is the moisture sensor. So we have to connect the moisture sensor, that particular pin, this particular no pin sensor uh, input pin to this particular A0, that is A0, and the power pin that is connected to the 3.3 voltage pin here, and this center one is related to the ground pin one. From moisture ground pin connection we given to the in the Arduino board, we are giving it to the pin number 13. Sorry, not pin number 13, it is a ground. Okay, so we are this ground, we are in the moisture sensor, the ground connection is connected to the ground pin in the Arduino UNO, and A0 pin input, this particular moisture sensor input is connected to the A0, and the power connection is connected to the 3.3 voltage, this particular red connection. Okay, this is the power connection. The power point is connected to the on the Arduino board, we are connecting it to the 3.3 pin related to the power connection, and the center one is related to the ground connection. The ground point is connected in the Arduino board here to the ground pin, and the input related to the sensor matches sensor point, that is connected to the A0. You can even connect to A1, A2, A3, A4, A5. In the program I written it as the A0. That's why we are connecting this particular input moisture sensor to the A0. And coming to the program, so we are using the C plus program, okay, to execute this circuit diagram. Okay, we are using this particular program. Here we are specifying as like integer moisture value. So this integer moisture value which declares the integer variable to store the raw analog reading from the sensor. So that whatever the input here, we already connected the input of this particular sensor to the A0 to read that value, and for that one we are using this particular integer moisture value. So this integer moisture value declares a integer value to the to store the raw analog reading. Okay, and next we use the code float moisture percentage. So this particular float moisture declares a floating point variable to store the calculated soil moisture percentage. Okay, this particular float moisture declares a floating point variable to store the calculated soil moisture percentage. So to store that calculated soil moisture percentage, we are using this particular float moisture. Okay, and after that we use the void setup. We already know that to in the this particular Arduino board, whenever to start or to or whenever you are setting the reset option, then always you have to use the void setup, okay, to initialize the functions. Okay, and after that we are using the serial dot begin 9600. In the last class also I mentioned that this particular serial dot begin which initializes the serial communication with the connected device. So we are connecting the Arduino to the computer. So it initializes the serial communication with the connected device, that is computer, at a baud rate of 9600. Okay, so that's why we are using this particular serial dot begin, and after that we are specifying the void loop because to execute the uh, program repeatedly, for that we are using the void loop function, and there we are specifying the code as moisture value is equal to unlock read A0 because our input pin connected to the that sensor input pin is connected to the A0. That's why I am specifying A0 here. Okay, this particular moisture value is equal to unlock read A0. This reads the unlock signal from the sensor pin connected to A0 because we connected a sensor pin to the A0. That's why it reads the analog signal. So that reads the analog signal from the sensor pin, that is moisture sensor pin connected to the A0. So the unlock reading will be it will be an integer value between 0 to 1023. Okay, the unlock reading it will be an integer value. The range will be from 0 to 1023. Mainly this particular moisture value is equal to unlock read, which reads the analog signal from the sensor pin connected to A0. The unlock reading is a integer value. The unlock reading is a integer value between 0 to 1023. So after that I use the code as moisture percentage moisture value by 539. Okay, so because this particular code converts the raw sensor value into a percentage. Okay, here this particular line of code which converts the raw sensor value into a percentage. Here the constant 539, here the constant 539 is assumed to be a maximum value for the sensor output, whatever the sensor we taken. Okay, that this particular why we taken is because the maximum value for the sensor output what we taken is the, for that the value is 539. Okay, the constant 539 is the assumed to be maximum value for the sensor output under dry conditions. So, and we are dividing it, okay, and converting it to the percentage. Okay, whatever the moisture value is read by the sensor, that value divided by 539 multiplied with the 100. So okay, after that we use the code as serial dot print, which sends the data to the serial monitor. Okay, this serial dot print sends the data to the serial monitor and displays the moisture value, which displays the moisture value. Okay, so it will display the moisture value in the this particular serial monitor. We are using the code serial dot print. So serial dot print we are using, and it will send the moisture value, and that in the serial monitor it will show the in the percentage form. Okay, and and we are, at the last we are mentioning the delay like 1,000. So like for every after once after displaying the moisture value, it will the code will stop for 1 second, that is for 1,000 millisecond, and after that again it will execute the loop depending upon the condition. Whenever the sensor detects again after the uh, 1 second, it again display the moisture value. So that is how we are writing the code. That is explanation related to this particular code. Now I will show the entire this particular circuit, how we are to connect to the different components that to the Arduino. Especially we are connecting the moisture sensor to the Arduino. I'll show all these connections by using the Autodesk Tinkercad software. So in the Autodesk Tinkercad software, you uh, create this plus symbol, that is to create the circuit. Okay, so once after creating the circuit, okay, default in by default the it generated one file name. Okay, you change the file name, so I'm changing it as because the experiment number 9, so I'm changing it as exp9. Okay, experiment 9. Okay, so after that you click on the Arduino board. Okay, for better, okay, this one you can zoom in the work area to reduce the size of the display, that Arduino board. And after that you select the moisture sensor. This is the soil moisture sensor. You click on that and you put it here. Okay, you can see that there in the moisture sensor there are three pins are there. One pin is related to the power, another one is related to the ground, and this one is related to the signal. Okay, in the moisture sensor, soil moisture sensor, there are three pins are there. You can see here, this one is the power pin, and this one is the ground pin, and this one is related to the signal pin. So you connect the this particular signal. This is the input pin, sensor pin. You connect this particular one. Okay, you can change the wire colors, or you can use the same different one. So I'm using the green color. Okay, so I am connecting it to the A0 in the Arduino. So you can connect it to the A0 because in the program written as A0. Okay, so after that you connect the this ground pin. Okay, this ground pin you connect it to the ground point in the Arduino. Okay, so this is the ground. So I connect it to the ground. I am changing it to the color black. Okay, so after that this one is the related to the power. So this power pin in the moisture sensor, you connect it to the 3.3 volts in the point in the Arduino. So I am changing the wire connection to the to have the difference. For that I am changing the color to the red. Okay. So we are connecting to the this particular no, uh, power connection in the this particular one, okay, to the 3.3 volts, and the input of the moisture sensor is connected to the A naught, and ground connected to the ground in point in the Arduino. So after that you use the generate the code. For that you click on the code, and after that you select the option text, and you will it will display a pop-up message. Are you sure to want to close the block editor? If you click continue, okay, then it will display the default code. We are using the C++ mode code. Okay, click the default code and erase that entire code, and after that you type the entire script of program in the text box here, or for a time sake I am pasting the content here. And after that, to check the simulation, you click on the start simulation. Okay, open the serial monitor to check the output. So it is showing the moisture value. Why? Because it is at the not we are operating the sensor. To operate the sensor, you click on the in the work area, you click on the sensor. You can get the this particular no symbol. Okay, you can slide the sensor. You can see that whenever I'm sliding this particular sensor, there is a variation in the sensor value. Okay, whatever the depending upon the its wet and dry condition of that particular condition, it is the sensor sensed the value, and after that the sensor value is converted into the percentage. So if I want vary this particular value, so I am sliding this sensor symbol here, then it is varying the, so maximum it is 100%. Okay, minimum is the like this 0. So if you slide this one, there is a variation. Okay, so that is the how we have to uh, now vary this slide bar to see the moisture values. Okay, if you want to edit the code, you can stop the simulation and you can put your cursor here and you can edit the program. Okay, in simulation mode you cannot edit the program. Okay, to check the again uh, like that particular percentage of moisture, you have to always click the serial monitor at the below. Okay, if I want to check again the like size to display the moisture values, you click on the start simulation. Okay, it won't it will show default value as 3. So we have to adjust this slide bar. That is, once you are clicking on the sensor, a slide bar will be appeared on the screen. You slide this slide bar, then you can see that there is a variation in the sensor value. So that's it, students. So today I explained the procedure, program, and how to do the wiring, all these things related to the calculation of moisture content by using the moisture sensor. Thank you all for listening to my class. Thank you.